Welcome to an Agisoft Photoscan tutorial. We are going to add photos to a workspace and build a digital elevation model, a mesh, texture our mesh, and all of the workflow that goes with that. So the first thing to do in the software is add photos. You can do that under Workflow, Add Photos, and navigate on your computer to where your photos are stored, which I've already done. Select your photos and add them using the open button. So this is the model space. It shows you where your photos are aligned, and this is how you can turn on and off the cameras. The cameras are showing the EXIF data from the UAV, which is the GPS locations of each photograph. And what the software is going to do is it's going to align like points from successive photos. So this is the workspace where you can see what you brought in. So here's my photos, for example. And the next thing I'm going to do, now that I have these photos, is I'm going to align them. So again, under Workflow, go down to Align Photos. We're going to use medium accuracy on this because for the nature of the demo, I want to get this done quickly. These settings are all fine. Make yours look like this while you're doing it. And go ahead and let it run. And this step can take 10 to 20 minutes, depending on how powerful your computer is, etc., etc. So, after you align your photos, you should get something like this, which is your point cloud. So the software creates a point cloud from like points, like we mentioned. I'm going to turn off the camera views because they get in the way, make it a little difficult to do the next step. What we're going to do is we're going to refine this point cloud and generate a dense point cloud using this data. So in the first refinement, we'll do this here under Module, Gradual Selection. There's a couple different selection tools here. We're going to use the Reconstruction Uncertainty tool. And what this does is it selects points based on the reconstruction uncertainty. So I'm going to go to about 40 to get all of these outlying points that came from the backgrounds of the photographs that we don't really need for the area that we're working with. So I've got those points selected, and I'm going to delete them. You can use this or the delete key on your keyboard. Another way to get rid of points that works pretty well in detailed areas, so if you're working with 3D models, for example, is to use these selection tools. I'm going to use the freeform selection and select the points like this. So again, delete on my keyboard and delete those. Oops. Delete those. And one thing you'll notice is after you've made a point cloud, this region here has been automatically created by the software. And you can refine that region to only include the area of interest for your project, which I'll show you how to do right now. So now I think I got all the points I want. Now I'm going to find this region. Oops, I accidentally grabbed some points. So a quick way to deselect those is to use this tool again and have a slider all the way at the max. And then just hit cancel and it deselects those. Then I'll click the navigation tool to rotate in my model space. So I've got this about where I want it, and I'm going to adjust this region box so that the software only creates the point cloud in the region that I'm specifying. So first things first, I'll resize the region. And the dark red on the bottom represents the ground. So keep that in mind. All right, that looks good. And the other options are to move the region and rotate the region. And if you don't like what you did, you can always start over. So I'm going to go back to the navigation tool and take a look at it. I can get it a little smaller, so I'm going to resize it one more time. All right, I think that's pretty good for what we're doing. One more small selection here to remove. And next up, we're going to build our dense point cloud. So in the workflow, go to build dense point cloud. For this tutorial, we're going to do this on medium, and this step usually takes a while. The depth filtering is something that you'll vary based on the terrain of what you're modeling. So for a model like this that has a lot of elevation change, we want to be aggressive. If you're doing an open field, like a soccer field or something, mild is fine. And if you're doing a 3D model, something with a lot of change in shape, you definitely want to be on aggressive. So we're going to run that, and usually this one will take 10 to 20 minutes, depending on your computer. But like any good cooking demonstration, I already have it done in another example. So here's what a dense point cloud looks like after you finish it. And you can see I've got some holes right here where the software didn't quite pick up what we wanted to do. And unfortunately, that's just the way it goes. If I would have ran the model at a higher setting than medium, it would have probably filled those in a little bit better. So from our dense point cloud, we are now going to build a 3D mesh. And the way to do that is pretty simple. With the software, you just go back into the workflow and select build mesh. So we're going to do a height field, and we want to use the dense cloud we created as the source data. And the face count, high is fine. You can even get away with going a little higher if you want. This should run pretty quickly. Interpolation is fine. And we're going to go ahead and create the mesh. And keep in mind, these holes right here, watch what happens to them once we build this mesh, compared to some of the other points that are a lot better defined. And so we finished building the mesh. If it hasn't shown up for you, if you don't notice any visual changes in the workspace, you can see the 3D model that popped up. And go ahead and double click on that. And here's our mesh, which is basically just a 3D model created from the dense point cloud. So it connected and interpolated different points and matched textures as much as possible. So in some areas, you can see things like these cars don't quite look like cars just yet. And again, like I mentioned, this area where we had holes over here filled in pretty poorly relative to the rest of the surfaces. So one other thing we're going to do in order to make this look a little better for visual analysis more than anything is we're going to build a texture. Let me show you where that is one more time. It's under the workflow, build texture, generic, and go ahead and do that. This will take a little bit of time. The only thing that should take a really long time is the dense point cloud. Everything else should be under 10 minutes based on the settings that we're using. Now the texture is finished, and as you can tell, when we get in at a little closer detail, things look a lot better. And hopefully that didn't take too long to run as well. The last thing we're going to create is a digital elevation model. And the way you do that is the way you do most of the things. You go under the workflow, you go to build DEM, and you're going to want to make the settings look like this. Use the dense cloud, not the sparse cloud or the mesh, and go ahead and hit OK. So your DEM should show up in your workspace and looks something like this. There's a few options you can play with to change how it appears. And the last thing we want to do is we want to do a little bit of analysis on our elevation model and then export the results. So the first thing we're going to do is we're going to map a profile right here. And the way you do that is you go to Model, Draw Polyline. It's also right here. And you left click to make your polyline. And we're going to go right through this right here. And you right click to end the command. And then I made 5 points. So if you right click on one of your points and go to Measure, then the software will calculate the latitudes, longitudes, and altitudes of the points that you made, as well as the perimeter or the length. And then under the Profile tab, you can see the general shape of the digital elevation model along your polyline, and is also the length here. We're going to save that. There's multiple file types you can save your profile under. I'm going to make a JPEG. And it looks like I already saved one, like a good cooking demo. Then I'm going to put that away. Next, I'm going to make a polygon to measure a volume. And I'm just going to measure the volume of the seating area. Again, you left click to make a point, and you right click to end your polygon. And then right click on one of your points and select Measure. And this will show you again latitudes, longitudes, and altitudes of your points, perimeter of your shape. Here's the profile of the shape. And about right there, it looks like I picked up something a little funny along here where I got a little too far outside of this flat area. And the nice thing about polygons is you can look at a volume with a polygon. So there's 3 options: a best fit plane, a mean level, and a custom level. Best fit fits the points as best as possible on top of the digital elevation model. Mean level averages all of the points that you selected. And custom, you can just add an arbitrary elevation. So for example, 1500 is well below our surface, which you can tell is at 2000, but on the other hand, 15,000 is well above. And so I'm going to stick with the best fit just for our purposes. And it gives me this nice volume measurement that I can report back to whoever needs me to perform some analysis. So now that I have that, I'm going to export my DEM, which is right here in the workspace. You right click on it and you go down to Export DEM. And we're going to use this first file type. And I'm going to do a raster transformation because I just want this as a JPEG. So in order to do that, you set your raster transformation to palette and you hit export. And when you go to save this, you have a few file types. I go with JPEG and I name it DEM and I save this. And that's all we're going to do in this demo. We've processed some basic photograph data. We made a few different results from that data, and we've saved some analyses we did. So thanks.